This has got a kind of a live demo throughout, and you can view it from your own device. So I'd encourage you to kind of like load this up in a different window or on a phone or a tablet, and you should see "Hello GeoMob" at the moment on a black screen, but it will update as I'm going through stuff. So yeah, we'll kind of see that happening. So yeah, while you visit that, that did not work. While you visit that, I can tell you who I am. So yeah, I'm Ben Foxall. I'm based in Dublin at the moment, and I'm usually back and forth to Oxford, but I'm pretty much here at the moment. I'm on Twitter as Benjamin Ben, and yeah, like throw me any questions, or I'll be around later to chat as well. Yeah, so yeah, hi, nice to be here. So I work at a company called Oxbotica. We write software for autonomous vehicles. This is one of our vehicles in the picture here. I specifically work with the web team, so we're building all the kind of web tools for the infrastructure in between, like all the stuff that is required for driving fleets of autonomous vehicles together. So today, I was going to talk about some accessing some of the sensor data from the raw sensor data from these cars. So this car here, this is kind of mid refurbishing, so it doesn't have all the sensors on it, but this has got a radar at the back here. And we've also got a camera. There's a few cameras on the other side. And then we've got these two LIDAR sensors. And this one here is the one I was going to specifically talk about today. So this is a Velodyne Puck VLP16. It's been around for quite a while. It fits in your hand. It's around that size. This is it without its hat on. So you can see the lasers come out here and bounce off something and then get sensed on the other side. And this is constantly spinning around, sensing its environment. You can kind of download data sheets for this and like kind of how to access the data that comes back. Just a kind of brief overview of how this works and feels. So the sensor fires a laser at something, then that laser bounces back, reflects back, and the sensor times how long it took to do that and how bright it is when it comes back. So from those two data points, along with like where the rotation is, you can kind of work out where that point is in 3D space. And then what it does is that it just basically sends that data across the network. So just as is kind of in that format from that data sheet that I showed before. So what you can do is you can feed this into a computer, and that computer can kind of like work out where it is and what it should do next. But another thing we can do is if you want to kind of save this data for later, you can plonk it all into a kind of serialized file. So a PCAP file is like a pretty common format for this. And it's just a way of kind of storing network packets for kind of later interrogation or something like that. So what I was going to talk about today is taking this PCAP file and visualizing it in a web browser, just without any kind of like anything else, and just what options there are for that and what we can do. That's what I'm going to talk about. The reason why I figured it'd be good for this meetup and stuff was, although I'm talking about LiDAR data, the same kind of approach is applicable for any kind of thing, right? Like, so if you've got the format available somewhere of that data, you can kind of overlay it in the ways that I'm going to show today. So hopefully it'll be useful for other things as well. I've tried to kind of keep it quite generic. Cool. So the first thing that I was going to talk about is data, and I'm going to share my screen differently just now. Cool. Can you see that new area? Cool. Yep. Thumbs up. Thanks. So this is the dev page that you should hopefully have up on your own devices. Sorry, one sec. There we go. So you should have that dev page up, and this is the source code for this. So I can basically add exclamation marks, and that reloads, and it should reload on your own devices too. So this is how we're going to start. Cool. Right. So the first thing I was going to talk about is loading data into here, and I can reposition this. So this is JavaScript on the side. We can create a buffer of JavaScript. So this is a kind of a uint array, and that creates a kind of raw buffer underneath that is going to be numbered from 0 to 255. And I've built this thing that renders that content. So basically, we can see that raw data that we've generated here. As a human, it's quite hard to understand that because it's just like we don't really read binary that well. So what we can do is we can group these together as hex digits, which you might have kind of seen this before in other tools. We still can't, so you can now kind of see it a bit clearer, but you still have to kind of look into the data. So we can kind of let this be a bit more scannable by colorizing it. So this is basically just like showing it from blue to red, so you can kind of get an idea of the shape of the data. So we've got this kind of like this rudimentary way of displaying raw data. What we can do is we can, instead of generating the data here, we can actually take one of those packets and feed it into the same UI. So I'm just gonna then buffer UI.render buffer. I think that's gonna work. And so I'm just going to take this out here. So instead of that data that we generated, I'm going to show one of those data packets. And so this is one of the raw packets from that LiDAR. So you can see we've got some bump up at the top. There's a bit of a kind of structure to it that you can kind of play around with. And if we switch this to a second packet, we can see that kind of change. So you can kind of flip between the two and get a feel for it. And there's also a lot more data in this one packet as well, but I've just truncated it for ease of use. Cool, so we're able to kind of view that data. The next thing I was gonna talk about is streams. So what we did was we had everything in that PCAP file, and I've got a little wrapper which we can basically read from a PCAP. And so this is a 10 megabyte PCAP file, and we can read this and it will emit those packets in the time that they were captured. So we're gonna import that. And we're going to slow it down by 100 times just because it's quite rapid data. And we're going to send that to the same UI. So we're going to pipe that along. And now you can see it kind of updates as those packets are going through. And you've got this button up here, which you can pause it and have a look. And you're kind of getting more of a feel for the data. You should be able to see this on your own phones and stuff like that as well. Cool. So yeah, this uses web streaming API, which is really cool because so this is a 10 megabyte file, but the first bytes that come down, you're able to view it because of the way that we're accessing it, which if you're into JavaScript, that's cool. Cool. So we've got that data, we're able to display it. We might want to use a more kind of richer API. So I'm going to use Canvas, which is a quite low level drawing API for for drawing like rectangles and stuff like that. So we can replace our viewer that we've got here. So it was that byte viewer, but instead we're going to replace this with Canvas. And what it's going to do is take each of those packets, decode it based on that schema that we saw before, and then draw rectangles for each of the points in the data. So here we can see that same data rendered to a canvas, and you can start seeing some of the kind of like the laserness of it. Like it feels quite kind of like you can see almost like the flashes as it's kind of scanning around and pushing that data past. What have I got to here? Yeah, and so we're showing the colors here, where the color is based on the intensity of the return beam, so which also relates to the reflectivity of the object that is hit. And the height is about the distance. So kind of bigger objects are closer to you. So that's what that means. We're drawing one packet to one screen. So it's like one-to-one thing, but we can change that and draw multiple packets based on the rotation of that sensor. So I'm going to do canvas wide, which is exact same UI, but now spread across. So now we can start seeing the actual kind of structure of the scene, right? Like, so you can see there's some objects here. I think this is a car. This is actually upside down because I made a mistake. But yeah, we can start seeing this content coming through. Did I do everything with that? Cool. Yeah, so the next thing, WebGL, so we're drawing that straight to the canvas, but another thing we can do is we can instead take the data, plonk it into a buffer, and separate the viewing of that buffer using WebGL. So this is basically the same kind of adding a pipeline into it. So if I switch to this viewer, WebGL, what we can see now is you'll see it kind of sweeping across in a second. In fact, do you know what? I'm going to speed this up. Right, so you'll see it sweeping across. So we've got that same kind of view, but because we've separated the data collating versus the visualization of it, we can actually kind of spin this round, and you'll be able to do that on a touch device too. And further than that as well, because we've got the distance and we can map that into 3D space, we can actually kind of zoom out and see the actual kind of space that is being captured by that LiDAR. So we can kind of like explore this around like that. And so we can start making out things like this is a car, there's a person here. Yeah, some other things. One of the nice things about this is by separating out, we can actually do this a lot more efficiently. So just now we're on 1/20th of the speed, we can actually just increase this to real time. So if we just take out that, then we're getting, actually I'll change this to be in the top. So now we're actually kind of seeing the live replay of that data from that PCAP file, just all in JavaScript. And you can kind of like see stuff around like that. Cool. Right, so what we've got here, so we're just, another aspect of this pipeline that we've created is that you can alter the way that things are rendered. So I've got this thing called a shader. So just now we're drawing the color based on the intensity. So if I take that off, everything's the same color. But what we can do is we can change this to be stuff like color from distance of the sensor. So now we can only see stuff up to 30 meters away, and you can kind of play around with these numbers. We can do all sorts of fancy effects like fun rainbow things here, and we can even use stuff like time as a variable, so we get animated effects. So we get this kind of like flowing, kind of cool looking thing. So yeah, and I've got a couple of things here. Yeah, actually, I won't go into those. Oh, yeah. So we can also do the same thing. I will go into this. So we're altering the point size, so you've got perspective here, but you can do things like weird things. So this pulses it in time with the reflectors, with the reflectance of that object. So basically, high reflectance objects pulse faster, which is a really useless visualization, but it's kind of trippy and nice. Have I done everything with that? Cool. Yeah, nice one. So the next thing I was going to talk about is Webxr. So one of the nice things about using the web is that you can host it on all kinds of different devices and browsers. So like on phones, tablets, all that kind of stuff. But by using Webxr, which I'm just going to enable here, this allows us to do augmented and virtual reality. So sorry, I explained that wrong. So basically, yeah, browsers run on all different devices. One of the devices that it can run on is this, which is a VR headset. So this is an Oculus Quest 1. There's a newer version out here. And I don't think I've got time for a real demo, but I'll show you a video of what this feels like. So this is, oh, sorry, one sec. Yeah, I'm going to just switch the sharing around to be just this one here. Cool. So you should be able to see that now. So basically, this is through this VR headset, visiting that same URL. In a browser, you've got a 3D space, and you've got these, you can use your hands to point at stuff and click on things. I'm going to click this Enter VR button. And what that's going to do is it's going to take me from viewing the web page normally to viewing it immersively. So this is like within the data, right? Like, so you're able to kind of look around, you can see that kind of weird, trippy pulsing thing, which is kind of weirdly relaxing. And doing this lets you kind of see the data in a completely different way. Like you can kind of notice things that you didn't notice before, right? Like the kind of how high things are, or how kind of close things are to each other. So that's a kind of fun thing. The other nice thing about Webxr is like, so VR headsets are cool, but not everyone has them. But Webxr also allows you to do stuff on mobile phones. So what I'm going to do is I'm just going to quickly cast from this device here. So sorry, this takes a second. Screencast. So Ben Foxall, and I'm just going to have to switch my share to this. Cool. So hopefully, can you see that? Thumbs up. Cool. Right. Okay. So we're on that web page again. I'm just going to reload this. And as you will hopefully have seen, you can kind of like play around with this on your with your finger. You can like zoom in and out, do all that kind of stuff. But we've also got this Start AR and VR button on this phone. If I do Start AR, it will fire up augmented reality. You can see OU, and we can see that same data here with exactly the same kind of code running. And this we can kind of like look right into it. It's a bit hard to share because it really kind of makes a difference when you're walking around the data and kind of being part of it. So yeah, that's us back to the web view there. Cool. So I'm gonna have to share my screen again. Portion of screen. Okay, cool. I'm gonna go back to this. Cool. Yeah, so that's Webxr. So we've got yeah, VR, AR, both rolled into this one thing, and in the future this could be totally different types of interfaces like holographics, tables, or whatever like that. So yeah, these are some things that you can do with the web using this kind of data. I'm just going to quickly, I think I've got like a minute more. So this is the kind of, I just want to show you quickly the stuff that we're doing at Oxbotica with this. So this is some more data from a different LiDAR, and you can see how much more we're getting from it and how much wider it is. We can capture that same thing over a period of time. So this is a car driving outside our office, and this is all rendered with the web. But we're able to load point clouds for that 20 meters of distance, and you can we get a lot more data, and you can kind of render it in a similar kind of way. We can play around with shaders and use that to kind of investigate the data and explore it a bit more. And we can do stuff like kind of looking at reflectivity and stuff. Something that's kind of nice is we can, because I showed you that car before had multiple sensors on it, quite a simple fun thing you can do is you can combine those sensors by projecting images into your point clouds. So this one here, we've combined the front cameras on the car and able to colorize those point clouds based on that. And you can kind of see here, the back is in black because the cameras are pointing forward. And so we're kind of getting all that kind of stuff. Cool. I think that's me, but I've got one last kind of thing to pitch, which is I help run this hack space every month. So we're remote hack, and it's this Saturday. If anyone wants to come along, or if anyone knows anyone who wants to come along, give us a shout and drop in. Yes, remote hacks, remotehack.space. So yeah, the more the merrier. It's a really fun thing. And that's me. That's totally me. So thanks a lot. I'm on Benjamin Benman on Twitter. Come to remotehack.space, and if you're more interested in what we're doing at Oxbotica, come visit that as well. So thanks a lot.